just watching through your stream and was listening to what he had to say.
Yeah, we had to get him on. He's a self-identified vibe coder. So, what about you?
No
What's your
worries.
background?
Uh, I'm actually a pre-final year student based in India, and I'm more into like development and freelancing than the DSA stuff. And since I saw your channel, I got to know that it's quite significant for us to study DSA and go into competitive programming to get jobs in FANG. There are not much resources out here since we don't have like high level stuff and those universities which like MIT and other stuff. We do have IITs and high level institutes, but again, as I said, we don't have much cultural awareness about these stuffs.
In India?
Yeah, we do have competitive programming and other stuff, but I'm talking about like niche level universities like tier 2, tier 3 colleges.
Okay. So let me think about this. So you're in like a tier two or tier three, and your school is not teaching you DSA. So how are you learning? Like through YouTube and stuff, kind of.
Yeah, YouTube. I got to learn about Tourist, if you know him, Code Force's Grandmaster.
Nice.
Yeah, so I was inspired by him. Then I saw that he's such a prodigy. Then I thought, let's try and see what it has to offer.
Yeah. So like when you were watching you said you watched my videos and you kind of it made you think that it's important. Like
Yeah,
why do you think it's important to know data
uh,
structures and algorithms?
like I saw several interviews where children of my age and even younger were like experts in developing algorithms and other stuff. And as I said, I'm into freelancing. So I got to know like this person you just interviewed, he talked a lot about vibe coding and other stuff.
Yeah.
The thing is that vibe coding doesn't get you too far. At some point, you need the basic underlying understanding of data structures, algorithms, as well as the niche crux, which you need to develop standalone applications for clients, if you know what I mean.
Mm-hmm. Nice. Cool.
Yeah.
Yeah.
So,
How far are you in your coding journey? And you're still in school. You're saying?
yeah, I am in my like third year university.
Nice. What have they taught you so far in there? Like what's the
Man, they
curriculum
teach
like?
every single language in a single semester. Like, to be honest, we just had a subject named web development, and there existed like five languages teaching you different stuff throughout the like semester. We couldn't focus on single language. As soon as we started getting hold of something, they instantly switched to another, and transition was so like drastic that we couldn't understand what was going on.
Damn.
Like heavy stuff, but not to complain, it is what it is. We have to do our own journey, and everything would be, I guess, sorted if we do it on our own way.
Yeah. So how many questions have you solved?
Around 287,
Wow.
as of today 290.
As of today, 290. That's a lot. Okay.
That's a
I'm
lot. You just joking, man. You have 600 and
this like the going from 0 to 250. I would say going to 0 to 300 is the hardest, and then after that, I've done it over the span of 5 years. So
5 years.
yeah.
Okay.
Okay, I sent you
So
the
it's
link.
like a resilient journey, to be honest. Okay.
Well, yeah, like I've been through three interviewing cycles, as in I changed job three times. Well, first my first job was getting or first was trying to get into the industry. I did about 300 lead code questions just to get my first job. Between my
Okay.
first job and my second job, I did 200 more questions, and then
Hmm.
like getting to fag like another 150 questions, kind of. So it's not like
Hmm.
you just should spam 700 questions in one studying cycle. That's I don't know if that's the most use of your time, but I would say at least solve a couple hundred, maybe 300 before like during one cycle, and then over the years, I'll probably be having to do leak code for decades. At some point I'll have 1,000 questions done, but that it's not like I'm doing all at one time. It's a balance, right? I need to balance leak coding, actually learning real stuff like projects, and actually doing well at my job. All these different things like family, all that stuff. Like There's more than just spamming leak code, but
Makes sense. Okay. So the first job you had was from direct like selection from the university itself.
well, I did internships, but I did all my internships in Canada, and then I moved to the U.S. for my first job out of college, and that wasn't to the university. I had to just apply for start. I wanted to join startups, so I was just applying at a ton of startups.
Okay, which is cool.
Okay, we're gonna get into the first question. And someone says, I've known people that have done less than 150 but got lucky in their interviews. And yeah, Eric, they got like the point in there is they got lucky with 150 questions. Unless you're really smart or you've seen the question before, you're probably gonna fail a good percentage of your interviews with only 150 questions done. I would say you'll fail at least half of your interviews, even more. And in a world where interviews are just hard to get, you can't afford to fail more than half your interviews if you're already only getting interview request 1 out of 20 interviews. So that's why you need to make sure that when you get your interview, you pass the interview. And how do you make sure you pass your interviews? First, you have to do leak code problems by yourself. But then you actually have to do things like Siddharth said here, like or what he's doing here, hopping on a coding interview, and I'll test him right now under pressure in front of 40 people watching and see how well he does and give feedback. And you could simulate this by yourself too with all your friends in school. I think when I was first graduating, I was doing this a lot. Me and my friends, we would mock interview each other once a week. We'd force ourselves to hop on and solve questions. And it's like the funner, more like community way to do it. And I enjoy it a little bit better. Okay, Okay, how are you in terms of things like arrays?
I would say decent. Yeah, I have solved quite a few of array problems.
Okay, um, the first question I'm gonna drop in.
Uh, Sorry to interrupt. Can I switch the language to C++ if you don't
Oh
mind?
yeah, you could use C plus plus. You could use whatever you want. Feel
Okay.
in this interview, feel free to use whatever programming language you like. Feel free to run the code as much times as you like. We're prioritizing working code in this interview.
Okay.
So you this is a classic question, but there's a twist to it. So pay attention to the twist so we don't go the wrong direction.
Okay.
So we're gonna be given an integer of length n and an integer target. We need to find three integers in the list of numbers that the sum is the closest to the target. The closest, not exactly.
Okay.
Does that make sense? And I'll give a couple examples.
Yeah,
So
sure.
we need to find three numbers that when you add those three numbers up together, it's the closest to the target. Then and or pretty much figure out what the closest number is to that if you add up three different elements. I'll let you go.
Okay. Uh, so let me go through the problem statement once and then go through the examples. Then I will make some notes if you say.
Yeah.
Okay. So we are given an integer array nums. Okay. Should I make my notes right here? Okay.
Yes, please.
Okay. We would have a nums array, and our goal is to find nums I, three integers. I believe these indices should be different. Obviously, I think.
Yes, different.
Okay. And the goal would be the sum must be closest to them and not precisely that. Okay, so it's like using a threshold value which we can monitor if the sum is approximately equal to the target. Okay, so let's go through the first example. We have -1, 2, which is -1 and 2. This is exactly 1. Return the sum. Okay, three integers.
Three.
We have
Yeah.
this is 2. Okay, then -1, 1, and -4. This would be -4. Okay. Okay, so I got it. Okay. -1 +2 +1. This would be 2. And there's no other triplet which could have a sum less than this.
So the sum that is closest to the target is 2. If we add -1, 2, and 1, we get 2, and that's the closest to target 2, or target 1.
Okay. And in second scenario, we have 0 plus 0 plus 0, which is 0. And the target is 1. Okay. Okay, man. This is a different approach. I need to think of it. Hmm. The first approach I think of is just simply naive or brute force, which would have time complexity of order of n cube. And I believe this is not optimal. We don't have the constraints right now, right?
It a n cube algorithm is gonna time out as soon as n gets like any reasonable size. I would say so.
Yeah, makes sense. N cube would obviously. Okay, so we can just go past this. Okay, the second approach I am thinking of is it's like the threesome problem, but not exactly that. In threesome problem, okay, could have one and two, and then we could search for the nearest element that could actually get us nearest to the target. Okay, let me think. So we would have the first for loop. Let's say we iterate over the array elements from 0th index to the last element. Okay. The main thing would be to consider using a hash map for each element in the array. Firstly, I will store each element in this hash map. Okay. Uh, let's say I have stored all the elements in hash map -1, 2, 1, and -4. Then I would go through the array elements one at a time. We have -1. Okay. Then for j equals I plus 1. Okay. Let's say we have this. And then we could check for remaining sum. Like, let's see what would be the remaining sum after adding these two, which would be nearest to the target. Okay, let's say we have -1 and 2, which is 1. Okay, 1. Remaining would be target minus nums I plus nums j. Okay, now I have to think of how to handle the nearest third element. Okay. We have -1 plus 2, which results to 1. And we can find 1 in the hash map. Okay. Then I see target 1 minus 1 would be 0. I can certainly not find 0 in hash map. Okay. I think I uh,
So what elements
can.
are we storing in the hash map? Okay, you're trying to flip it sort of like to some where.
Yeah, I'm trying to associate it with the threesome problem. And thinking like I was thinking, we can certainly add up two elements and then we can search for the third in hash map. It's not necessary that it would exist. And then I'm thinking like I can use a while loop such that I find the target somehow inside this. Like I can just keep on increasing this rem sum until I find the element in hash map.
Okay,
Like,
let's talk about this for a second. Let's go back to the
okay,
naive solution. How would what would be the naive brute force solution to generate this?
okay, naive solution would be three for loops, and then we can certainly add them up, which and store it in a sum variable, and then we could like keep a buffer which would store the minimum difference between the target and the resultant sum, and
Yep.
we could we could search on this difference. Like we could keep a counter for minimum of this. Like let me make some. Like we could make a variable sum. Sorry, nums I plus nums j plus nums k. Hopefully
Mm-hmm.
this is clear. And then I would find a difference which would be target minus the sum.
Yep.
And then I could check for, I could iterate for the minimum difference that is available in the
Yep.
entire traversal.
That makes sense. Okay. What's the slow part here? What's causing it to slow down?
The third loop, I believe,
Okay.
uh, and then we have to iterate for the
Okay.
difference to be minimum also.
Okay. Pretend that I was just looking for a specific target. Let's work on that first. How would I speed it up? Like I was just looking for one target. I
Uh,
was looking for the
just
exact
one.
target. Pretend let's just do threesome for now and we'll expand it if we need it.
Okay, okay,
Like pretend
makes sense.
I was just looking for the exact target then. How would I
Uh,
optimize this N3 algorithm and how good would it get?
okay. Uh, we can certainly account for this third loop and reduce it to an order of n squared solution. Like we could add these two elements and we could search for the third element in the hash map. If this element exists, then we have found our triplet.
Okay, how would
I
that look
think
like?
uh, how would that look like?
Yeah,
So
can you
do you
explain
want me
further?
to pseudocode? Okay, let me
Yeah,
dry
just
run through
okay.
the
You could
example
just
itself.
yeah. Let's dry run it through a very simple example. Pretend
Okay, let's copy this example and run it here itself. Okay, so in the first iteration, we say we have -1 plus 2. This gives us +1, right? And then we could look up for 1 in the hash map. Since we already stored each of the elements in hash map, our hash map would look like this. We would have 2, and then we would have 1, and then we would have -4. Okay, so our hash map would look something like this. And then we could easily look up for 1 in the hash map. And if we find that we have found a possible triplet, which would be uh, -1, comma 2, comma 1. So we have found one of our,
but how do you know that it's not one of the elements that you're already looking at?
uh, by accounting for the indices, I think.
So
Instead
for
of I,
example, okay, let's run through a very small example. So we
okay,
have -1, -2, and then pretend we have -4. One -1 equals 1. Pretend the target is -3, right?
-3. Okay,
So how would you
okay,
run your and then generate me the hash map as you're doing this. So we have a hash map. Generate me the hash map or the solution. You're gonna and also show me how the pointers are gonna behave.
okay, certainly. So first of all, we will start by populating our hash map with the value and the index it is found at. So it would be -1, 0, since -1 is found at first index, then 2, 1, then 1, 2, and similarly -4, 3. So this would be the hash map.
Mm-hmm.
Okay. So now let's account for the pointers. In the first pass, we would have, yeah, certainly like this. And then we would have second loop, which would point to 2.
Mm-hmm.
Then the sum of these two elements would be -1 plus 2, which is
Okay.
1. Okay, right? So now we have to find our element such that so we need 1, So we need minus 1 plus 2 plus something which is x such that the target becomes minus 3,
Yeah.
right? So
Mm-hmm.
we can rearrange this equation, form it minus 1 plus 2 plus 3. Sorry, we could keep x here. This would be minus 3 plus minus of minus 1 plus 2. Okay, hopefully I'm clear. So
Yeah.
we can find the remaining sum. Like the remaining sum would be something x, or better
Okay.
I call
You
it
just
x.
rearrange for x, and that will
Yeah,
equal
I just find for the elements,
negative
and
four, right?
then I can look for this element in the hash map if it exists. And I will make sure, let me just type it in. So it would be minus 3 and minus of this would be plus 1, and minus 3 minus 1 would be minus of 4. And we certainly have minus 4 as we can see. So we have lookup for minus 4 in map. Okay, so we looked up, and now we will examine the indices for each of these elements. Since these two indices would be already taken care of for, uh, this I say is I, and this if I say is j, which would be, start from I plus 1. So these two certainly can never meet in a single iteration, right?
Mm-hmm.
And then I can check if map of x is not equal to I, and map of x is not equal to j, then I can certainly assure that a triplet exists, and then I could just report the answer.
If I
So in this case, map of 4 would be map of minus map of minus 4 would be 3, and minus 1 was 0, and 2 was 1. So 0, 1, and 3. So we can easily
yeah. What
report
what
the
if, what
index.
if there's multiple negative fours? Would that cause issue?
If there's multiple negative 4s,
Because here you're only
no,
storing.
it won't cause an issue, I believe, since it would update the hash map to the last index of occurrence in the array nums.
I see.
Uh, like for example, if we have nums minus 4, and minus 4, and we are looking for something like minus 8, minus 12, right? So the map would look something like this, minus 4, and it would automatically update to the last index of occurrence in this. And then we can apply the similar algorithm and it will take care of itself.
Okay. Yeah. Go ahead and implement that code then.
Okay. Uh, okay, let me go through once what I have so far. Okay, so let me just, I think I would need to import, yeah. So I have imported the library utils. Okay. Okay. I can make a solution class for solving this. We are pretty far from the actual problem, if I believe
It's
still.
okay. We'll just work with this one, and then we could just move on to a different question.
Okay, okay. What does it want me to return? The sum, or uh, what does it want me to return? The indices of occurrence or the elements or
Yeah.
the sum?
The just the indices.
Just the indices. Okay. I can take in the target element. Okay, then I can solve for it. Okay. So first I would start by preparing my hash map, which in this case would be an unordered map. Okay. So I have my hash map and then I would populate it with all the values inside the nums and map it to the index of occurrence. Okay. So I should not do this. Should do.
Yeah, I think it makes sense. So let's move on to the next question actually, because I think I got a good grasp of your understanding there. I'm
Okay.
gonna I'm gonna switch it to the next question.
Okay.
Let me see something. So this is like a more of an interval one, kind of like a real world question. But pretend that we have a bunch of meeting intervals where we have the start time and the end time. This is the start
Okay.
time and the end time. What are the number of conference rooms that you need to have to handle all these meetings? So this one you need two meeting rooms because we have um, pretty. I think because these two over or we need to create a new meeting room because some of these overlap. Let me see. So if
Okay.
this pretend this one takes from 0 to 30, that's fine. Then we have 15 to 20. So what we can do is we can have a meeting room for this guy from time 0 to 30, and then 5 to 10 needs to overlap with them. So we need a new waiting room or new meeting room. But this person will be done at time 10, so we could go from 15 to 20 with this. So these two can share the same meeting room, and this can just do one.
Yeah, makes sense. Okay, so this is like scheduling problem.
Yeah,
Okay, so we need to schedule our meetings so that we use the minimum number of conference rooms, right? Okay. Given an array, meeting time intervals, where intervals is start to end. Okay, return the minimum number of conference rooms required. Running through the example, we can see 0 to 30, this would occupy the first room. And as you said, these two meetings could be accommodated in the second rooms. Okay, let's see about how about this 2 to 4. Okay, so this would take one room, and then we have 7 to 10. Okay, this could be accommodated in a single room, and hence we have the answer one.
exactly.
Okay, okay, so this is like a practical problem, resource allocation or meeting scheduling. Okay, looking at this, just by reading the minimum number of conference rooms, I think this is a greedy problem. If I'm going through the correct path, please do tell me. Just by looking at this, okay, greedy. Let's see. We have 2 to 4, and then we would have 7 to 10. Okay. So the first thing that comes to my mind is to sort the given intervals based on the start times so that we can just account for the start times, like which meeting should be adjourned or scheduled first and then followed up by others.
Sure.
Okay, let's see. Uh, we have two here, and then we have, okay, more like two is not of use. We have four here, and then we have seven. Okay, let's see if they overlap. No, they don't. So we can accommodate them in a single set. Like these intervals could be accommodated in a single room. And hence we could report the answer to be 1. We could just keep a counter and then we could increment it in case some meetings overlap. Now, let me run through the second example, I believe, or more like the first example.
Yeah, the first example is actually more complicated.
Yeah. So we would sort based on the start times, as I said, it's already sorted. And then we would have 15 to 20. Okay. Let's say we have a variable name meeting rooms, which will be initialized with 1. Of course, we need a single meeting room first. Then let's see. We can go through 30 and then we see it's 5. Since 30 is greater than 5, we do need a meeting room. So we would need to add one more meeting room to our like inventory or something we can select.
Sure.
Okay. Then similarly, okay, let me copy this. Now we would have this implies that meeting rooms are now two. Okay, then we can check for this. Now here is the case. Since 10 is less than 15, so the later meeting could be scheduled in the same room as the previous one. So we won't need another meeting room and then we could accommodate the same meeting in the same room. Okay. So there would be no effect on meeting rooms right now and hence we can report the answer to. Okay.
How do you know there's no effect on meeting room though? Like how would you look back to figure out if there's a open meeting room?
Like I'm checking the like for each interval, I'm checking the end time with the start time of the next one. And if I see they overlap or if they overlap, then I would need to increment my count for meeting rooms and else the meetings could be like scheduled within the same room. That's my like thought
Okay, wait,
process
wait.
in case there's something
Let me
I missed.
backtrack here. So we're at 15, right?
Right.
So I need to figure out. So what am I gonna do? I'm gonna look at the one right behind me to figure out if I need to introduce a new meeting room.
Right.
What if there's 5 and 16, right? So I look behind me. I know that I need to, or like 10. So
Okay, 10 and 16.
yeah. So I
Okay.
know, yeah, like I look back on here? It's like, do I need a new meeting room? I can't take this one, but I don't really need a new meeting room to introduce a new meeting room because this meeting room is going to be empty.
This would certainly be emptied, but if we look at this condition, like 5 to 10 would be the slot for this meeting, and then 10 to 16 would be accommodated for this, right?
Okay,
So
let's do
these
this
two
then.
meetings could be
6.
in the same.
So now we
Okay.
have three meeting rooms, and then um, if we run your algorithm, you're going to produce 4.
Okay, let me check. Since 30 is less than 5, yeah, we would need 2 here. Since 30 is greater than 5, 10 is greater than 6, and 16 is greater than 15. Okay. But we can certainly accommodate these two in the same meeting rooms.
Exactly,
That's what you are saying, right?
exactly.
Then the answer would be 3, but according to my algorithm, it's 4, which is wrong. Okay.
Yeah, exactly.
If 5 to 10, then we have 6 to 16, and then 15 to 20. Okay. So I think I would need a data structure to store these meetings, and then I can evacuate the room in case a meeting has ended. I'm correct.
Mm-hmm. Exactly.
So I could use a think. Let's see. Suppose I have first meeting room for this meeting, and then second meeting room for this meeting, and third meeting room for this meeting.
Yep.
Okay.
Exactly.
Now, in case of fourth meeting room, I can check if there exists any meeting whose end time just like is just before the starting time of my current meeting, right?
Yep.
And then I can evacuate that room, and then I could report the size of this data structure as the answer.
Yep.
So, okay. So I'm thinking of using a set data structure right now.
Okay. What would be the runtime? Like how would you find that room? If you search through all the rooms, that would be lead to more of an O n squared solution, right?
Okay, let me think about that. So we are using a single pass for populating. Okay, so suppose we have this inside the room 0 to 35 to 10. Okay, I think it won't take uh, long if I use n times. Okay, 5 to 10, 6 to 16, and 15 to 20.
Like searching for a room to evacuate is gonna take O n time,
Yeah, that's
right?
what I
Like
am
you're gonna
thinking.
be looking
How
through.
can I
Can I
optimize the
evacuate
search?
this? Can I evacuate this? Can I evacuate this? If you can't, you need to
Yeah,
condition them.
that's what I'm searching. Like, what could be used to optimize this? We
So
need an order of one lookup time so that
doesn't need to be
it's
O.
on.
It just should be just be what okay. In this data structure, what are you looking for? You're looking for
Any meeting which has a end time less than the start time of
okay.
my current meeting.
Okay. So which meeting would that be? Would it be so like if you're looking for one specific value, what value would that be? Like what meeting would has the highest chance of being smaller than your current time?
The one with the end time being so you were saying I can like store based on the end times of the meeting, right? Okay.
So okay, wait. I'll tell you this. Like so, we have this data structure, right? And it's telling us the end times of each of the rooms. We want to look for the end time that's smaller than our start time, right?
Yeah,
So,
totally.
so if we find the if we find the meeting room with the smallest end time, or yeah, with the smallest end time, like the earliest end time, that's probably gonna be the room to freeze up for. Like we're gonna look for the room to freeze up first, right? Because if that
Yeah.
room doesn't freeze up, if that room frees up, then we could use it. If that room doesn't free up before we have to start, then none of the rooms will free up, right? So how can we find the smallest end time in that data structure fast? Do you get what I mean there?
Yeah, I understood what you mean. You were saying based on the end times, and I was thinking about the start times.
Well, okay, we pretend we have a bunch of meeting rooms, right? We don't care when they started. We just care when they end.
Totally.
So if I just pretend I'm gonna go to a meeting room, I just need to know when is like what's the meeting room that's gonna end the earliest. That way I can try to go there. I don't want to wait for like one that ends after that or another one that ends after that because I'll be waiting too long. Like I'm just gonna look for
Makes sense.
what's the meeting room that ends the fastest or just ends the earliest, and I'll wait outside of that. Waiting if we think about it conceptually, right? So how would we kind of implement that?
Okay. So earlier I was thinking about merging based on the end times, which was somewhat correct, but it had wrong intuition. Okay, so I could use like something which makes this to the field. Okay, it sounds like sorted data structure such that the meeting with least end time is selected, and then no other meeting would be freed up, as you said, right?
Yeah. Well, I don't know
Would
what you mean,
be
but no other meat reading road free.
no. Uh this is like the crux of my thought process right
Yep.
now.
Go ahead. Yep.
Okay, so something like min heap would min heap or max heap. Okay, heap data structure. Okay, I think mean heap could be used so that we could place our meeting intervals based on the length of based on the end times,
Heap
based on the
basic.
end times. Okay, okay, let's see what it does. Min heap to account for meeting with least end time. First, we sort based on the starting intervals. I think that's okay. Then we would push each sorted meeting into the min heap. Then it would account for the meeting with the least end time. Okay. And then I could check if my current meeting's start time is like is in range of is okay more like is less than or equal to the top of the heap, then I could be certain that I would need more meeting rooms. Okay, this is just my notes. I would just go through a dry run real quick.
Sure.
Let's get so going through the dry run again. Should I go through with this example itself? Okay, let's go with this. So we have this sorted, and now we would start with iterations. We would first our min heap would look like 0 to 30, and then in second iteration it
I
would
think
look like
since we're
5 to
short
10
on
first,
time.
since the end time of
Sorry.
second meeting is less than the first.
Or I'm gonna say. Sorry, I was muted. Since we're short of time, just try implementing it. I think you have the crux of the problem. Let's just see if you can implement it.
Okay, okay. uh, so just to be sure, like is my thought process along the right lines now?
Yeah, yeah. Use a heap. The heap should be on by end time.
Okay, let's say
Yeah, go
we
ahead and
make
implement it.
yes, sure, sure. Okay, we don't have that imported. Okay, let's see. Running through the example itself, and then 15 to 20, we have our data structure ready. And then we could make a function int solve, which would take in this array. Okay. And any constraints of the interval I forgot to ask. Excuse me.
Constraint. Sorry, I had to do something. No constraint. Just implement.
No constraints.
Yeah, no constraint.
Okay. 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 Just sorting the intervals based on their start time first.
Yeah, just
Okay.
keep implementing it. It's like just grabbing
Okay.
something.
Then I could make priority queue, which is the main heap in this case. Then it would store the interval for each of this data structure. Okay. Then I need to make sure this is like organized based on the end times. Okay. So I need to make sure. Okay. So the greater of the later parts should be used. Like this simply means that we are arranging the main heap by based on the end times. Greater end simply means that. So we have this data structure right here. Okay. So we just begin by pushing the first interval of the interval set. Okay. Then I could iterate over the remaining intervals. And here I need to make sure that start time of current meeting if less than the top of min heap, then we would need additional meeting rooms. Okay.
Yep.
So I could just check for the counterverse of this, like for the start of each meet is greater than or equal to the top. Okay, so the counterverse of this means that I won't need additional meeting rooms, so the meeting room could be freed up.
Mm-hmm.
Okay, so I can simply pop from the queue, pop from the min heap, I mean to say. Okay, then I need to push the current interval end time. Okay, so the end time of current interval. Okay, okay, so we have this, and then after popping, whatever is the size of the data structure, as I said earlier, would be my answer, I believe. Okay, let me just. Okay, I have not invoked the function here.
The heap at the end.
Yes, please.
So you we're capturing just the mint size heap at the very end.
Yeah. This would be like the size of the data structure after we have popped up all the intervals from the min heap that from like those would be the rooms which could be freed up, and the remaining would be the number of rooms we would require.
Yeah, that makes sense. I'm just trying to think. Do we need to track it? Do we could we just return at the end, or do we need to track it while like during in here?
I think we could track it with a additional variable. We could keep a counter while popping and make sure. But according to this, I think this would make sure.
Nice. Yeah. Yeah. That makes sense. I was just trying. I didn't. I used for this one. I just tracked during the thing. But yeah, we're at
Okay,
50 minutes. How do you feel? How do you think you did?
uh, not good, man, not good.
Really?
I think I fumbled a bit. In the first question, I was totally like dodged. I have seen that threesome question. Uh, oh, I have not run it.
Yeah, I think you
Okay.
came up with a good threesome solution,
Uh,
but like,
I was thinking
yeah, go
about
ahead.
tracking the absolute, more like difference between the closest sum and the target.
Yeah, yeah,
Then we could track. In this question also, I think I was going through the wrong paths. Then you gave me a hint. Then I sort of started thinking along the right lines.
yeah. Honestly, the what I would say here though is you did really good at talking about your solution. I understand it where you're going the whole time. Like I understand it where you're going, and I was able to give you good advice. Cause I wouldn't say you were necessarily going the wrong direction, but you you just required help to get to the final solution. But you're moving slightly in the right direction. I was kind of just like nudging you and guiding you a bit. So I think as like for a junior candidate, I think you're gonna be applying for junior roles because you're still in school. This is a perfectly fine interview, and I would probably pass you on to the next interview, or I might have not would have not asked you something. Some of these were kind of hard, right? So I think things you did really well. You clarified the question really well. You were able to come up with various approaches coming from brute force to like somewhat optimal, but couldn't get to the optimal, which is fine in this case for your level. I think you obviously wrote the code and it worked. You understood heaps. You understood like sets. I mean, there's a lot of positives that came out of it. Honestly, I don't. I think you did a pretty good job. I don't know if I would pass you or not. It would more depend on how did the other candidates do. But I think you would have done better than a lot of other candidates at your age and level. But yeah, that's kind of my feedback. I think yeah, just I think when you come up with the solution, right? Or when you come up with the brute force, which you did well, try to figure out what's the bottleneck and how do I optimize it. So
Yeah.
I think that's where you're stuck on. You came up with the brute force and you're like, what's the bottleneck? Oh, I need to, the bottleneck is I have this solution and I can't find the next meeting room that is open. And then when I gave you that advice to think about it, you thought about it and then you came up with a solution. But I think your approach is good. Come up with a if you can't think of the optimal algorithm right away, and most of the time you probably won't, come up with a naive solution or a solution that definitely works, and then try to
Okay.
optimize it and see if it could optimize from there. How do you optimize it? Look for bottlenecks in the algorithm, and then try to solve it in the same way that we did it now. Even in the three sum questions, like how do we like kind of broke it down a bit better. But yeah, what do you think?
Hmm. Uh, yeah, I think that sounds about right. But I have noted a pattern in these problems that sometimes the optimal solution is like totally different from the naive solution. Like you have to think out of the box, and that's where I like kind of get stuck on.
Yeah. What? Why would you say you have to think out of the box for these ones? I guess.
Like for instance, like there are some problems in how do you like I was solving a linked list problem like last week or so.
Mm-hmm.
Then there was this problem like find the length of the cycle or something, and
Mm-hmm.
I was thinking like going through it once at a time, one time, like using a simple pointer and going through one at a time. But the solution when I looked on tortoise and here and fast and slow pointers, I was like, how am I supposed to like think of these
Yeah.
during the interview?
Yeah.
Like, so it depends. If you have seen the problem, certainly
Yeah.
you would
It's
be able
huge.
to.
Yeah. That's why I can't get. That's why I still think you did really well. You, like you're. It's more that you just didn't see the question and you couldn't think of the solution. So the only way to solve this is by solving more questions and just exposing yourself to more questions because there's a
Yeah,
lot of questions
certainly.
like this. Like there's a lot of scheduling problems that involve a heap. I know a few.
Makes sense.
So so yeah, like just have that in mind. And yeah, the three sum closest one is a little bit weird. So that's why we kind of moved on, but I still think I got some signal from that. But yeah, other than that, thanks for taking the time out to interview it for this one.
Okay.
All right, catch you. Peace.
Thanks a lot, man.
No problem. Good luck.